All right, today we're going to be solving equations using completing the square. We're going to complete the square. Now, this involves that we recall from when we did perfect squared trinomials, not difference of squares, but when we did that a plus b squared equals a squared plus 2ab plus b squared. When we would do that, or that, a minus b squared equals a squared minus 2b or 2ab minus b squared. We're going to harken back to those relationships a bit as we do completing the square. Now, there's 6 steps to completing the square, but it really kind of only feels like 2 steps, which is nice. One is that we need to arrange our equation so that it looks like x squared plus bx equals c. X squared plus bx equals c. Now that c could be 0, that c could be everything else moved to one side. So we need x squared plus bx equals c. Now here's where we get into completing the square. First thing we do in completing the square is we're going to take half of b. We're going to take half of b, so b over 2. Then what we're going to do is we're going to take b over 2 and square the quantity. Then what we're going to do is we're going to add it to both sides. Then factor. Now, the best part about when we add it to both sides is that we can go right to saying b plus 2 as our factor. So when we have ax squared, not ax squared, sorry, but x squared plus bx plus b halves squared plus b halves squared, x squared plus bx plus b halves squared, that equals the group x plus b halves squared. X plus b halves squared. So we can jump right to that factoring step pretty easily. Then we're going to take the square root of both sides. And then we're going to solve. But when we solve, we need to remember that we have 2 cases. 2 cases, what do you mean? You'll see in just a bit. So I'm going to keep our steps up here as we do some of these examples. Again, we're going to arrange it as x squared plus bx equals c. We're going to take half of b, square it, and add it to both sides, then factor. And then we're going to take the square root of both sides and solve for 2 cases. So if we have n squared plus 18n equals negative 77. So we're already arranged x squared plus bx equals c. Done. Now we're going to take half of b. Half of b being 18. Take half of that, which is 9. Square 9, which becomes 81. So we're going to say n squared plus 18n plus 81 equals negative 77 plus 81. Negative 7 plus 81. Now when we factor that, we get n plus 9 quantity squared. N plus 9 quantity squared. I'm going to simplify this side over here. And let's see, we get negative 77 plus 81. That looks like we have a positive, what am I saying? A positive 4. Positive 4. We take the square root of both sides. So we're going to have n plus 9, because a quantity squared, take the square root, we just have what's inside. Now, when I say 2 cases, we're going to have plus or minus 2, because we don't know what n is, if it's positive or negative, so we're going to have plus or minus 2. So now when we subtract 9 on both sides, we could have n equals negative 9 plus or minus 2. Meaning we could have n equaling negative 7 or n equaling negative 11. So n could equal negative 7 or n could equal 11. And there we have just solved by completing the square. So let's look at a couple more examples here together. we have b squared plus 2b minus 51 equals 0. We need to arrange this as b squared plus 2b equals a positive 51. So let's think, if we have b squared plus 2b, 2 is our b term, so we're going to half that. Half of 2 is 1, squared is 1, so we're going to add 1. So we're really going to have b plus 1 squared equals 52. Take the square root of both sides, and we have b plus 1. Now the square root of 52, we could say is 4 and 13, and 4 breaks down as 2 and 2. So you have 2 times 2, which is a pair. 1 will come out, 1 will go away. 2 equals plus or minus 2 times the square root of 13. So when we subtract 1, we have that b will equal negative 1 plus or minus 2 times the square root of 13. And that is our two cases. By keeping that plus or minus there, we have two cases. One would be negative 1 plus 2 squared of 13. One would be negative 1 minus 2 squared of 13. All right? I hope these steps are becoming a little clearer. Now, when we have 10n squared plus 20n equals 60. Now, all of this we did with it being x squared. So sometimes when we rearrange, we might have to divide everything. We might have to divide by 10, so we'll have n squared plus 2n equals 6. Luckily, factoring it is the same thing over here. So half of 2 is 1. 1 squared is also 1, so I'm going to add 1 to both sides and factor. So over here I have n plus 1 squared. When I add 1 over here, I get 7. When I take the square root on both sides, I get n plus 1 equals plus or minus the square root of 7, which then when I subtract 1 on both sides, I have n equals negative 1 plus or minus the square root of 7. Alright, so if we follow these steps, it should be pretty easy. So I'm going to bring these steps back up and try and come back and forth. So we need to arrange so that we have x squared plus bx equaling c. So I'm going to have to add 69 to both sides, and I'll get r squared minus 6r equaling now a positive 55. Sorry, not 55, 63. Silly me, 63. Now I'm going to have to take negative 6, half it, so negative 3, square it, which is 9, to add over here. So we'll have r minus 3 squared equals 69 plus 9, which is 72. 72 over on this side. So when I take the square root of both sides, I get r minus 3 equals, let's see, 72 breaks down as 8 and 9. 9 is 3 and 3. 8 is 2 and 4. 4 is 2 and 2. So we get, looks like plus or minus, we have a pair of 3's, a pair of 2's, 6 times the square root of 2. Now when we add 3 to both sides, we get that r equals 3 plus or minus 6 times the square root of 2. And that's our solution. That's if we solved, we now have an exact solution for some problems that we might not have been able to solve before using completing the square. Completing the square. Now, for our practice for tomorrow, we're on a worksheet 9.4 practice that you can find on my website under Worksheets, Chapter 9, 9.4 Practice. So, remember, our first step, we need to arrange so that we have x squared plus bx equaling c. So I'm going to add 18 to both sides and get b squared plus 2b equals 18. Now, my second through fourth step is all that doing the completing the square, where I take b, I take half of it, so 1, I square it, 1, add it to both sides. Here I'll show you that separating out. So we have b squared plus 2b plus 1 equals 18 plus 1. So this is really b plus 1 quantity squared equals 19. b plus 1 quantity squared equals 19. Take the square root of both sides. So b plus 1 equals plus or minus the square root of 19. Then I subtract 1 on both sides and solve, and I have b equals negative 1 plus or minus the square root of 19. Now, I know we got this b squared plus 2b a lot today. It's not always going to be the case, but it's okay to start recognizing patterns like that